Welcome to the F-14B Difference Training course. This first lesson explains the main differences between the older B version and the newer BU version. We will discover changes in system design, the cockpit controls and indications, and also in the procedures. We will not go into much detail, but only scratch the surface a bit. Press the spacebar when you're ready for it. Let's quickly look at the history of the aircraft. The older B version received several important upgrades. The whole process of upgrading the B version was gradual, with systems being added separately one after the other, and it started in the late 90s. The aircraft you are currently sitting in is a fully modernized F-14B, which has become known as an F-14BU, where the U stands for upgraded. The DCS F-14BU is simulated roughly in its 2004 configuration. It is now up to you to learn about the new features during the lessons of the difference training. Press the spacebar to continue. Okay, first, let's review the navigation system. The B version relied on its onboard inertial navigation system, abbreviated INS, which was based on inertial sensors. For alignment of the INS, the Carrier Aircraft Inertial Navigation System, abbreviated CAINS, was used on the deck of an aircraft carrier. On land-based airfields, the INS was aligned by entering the known coordinates of the current location, followed by a normal alignment of the inertial sensors. In flight, the INS position could be fixed by certain methods. In the BU version, this architecture is now modernized with a new navigation suite. The primary components working in the background are the embedded GPS INS, abbreviated EGI, and the F-14 mission computer, abbreviated FMC. The new system combines inertial sensors with satellite navigation, thereby removing drift and highly improving accuracy. Press spacebar to continue with the next steps, or simply wait a few seconds to get more detailed information on the navigation system. Okay, I will give you some more information on the navigation system. The primary navigation components of the BU version are the well-known TACAN radio navigation system, the new embedded GPS INS, or EGI for short. The man-machine interfaces in the back seat are the well-known TID, the new Control Display Navigation Unit, or CDNU. The EGI consists of an inertial measuring unit, or IMU for short, with ring laser gyros and a 5-channel GPS receiver. A Kalman filter combines the data of the IMU and the GPS, resulting in a navigation system with essentially no drift. The TID is now called PTID, simply because it is programmable. It offers functions for working with the navigation, the radar, and the weapon control system. The CDNU acts as the bus controller for the MIL standard digital data bus, which is the primary element allowing for the integration of a highly sophisticated navigation system and associated weapons. Let's quickly summarize. The EGI is an IMU plus GPS plus Kalman filter and delivers exact aircraft position. The PTID is the programmable TID and manages navigation, the radar, and weapons. The CDNU is the RIOS control panel and is the primary navigation input device. The EGI provides 3 separate position solutions simultaneously. These are GPS, blended, and free inertial. The GPS solution uses the timing signals transmitted by the Navstar GPS constellation of satellites to determine the aircraft's position near the Earth's surface. As long as 4 satellites are being tracked at a time, extremely accurate position determination and the exact GPS time are available, even when the EGI is in the alignment mode. The receiver also provides aircraft velocity in 3 dimensions, although during rapid maneuvering, the velocity information can lag slightly due to the update timing. The blended solution is the primary solution determined by the EGI and is available for use as soon as the EGI determines its drift rate is less than 5 nautical miles per hour. It uses a Kalman filter that both improves the quality of the IMU and the GPS, and also uses the GPS solution to refine the position derived from the IMU. The EGI has the ability to remove the GPS data from the Kalman filter. This is useful in areas of known GPS spoofing, for example. There are 2 blended solutions, which are aided blended and unaided blended. The F-14 uses the unaided blended solution when GPS aiding is not desired because it still uses the Kalman filter to improve the IMU position outputs. The free inertial solution cannot be used for navigation purposes by the CDNU or FMC. Press the spacebar to continue. Next, let's look at the cockpit instruments on the pilot seat. The most obvious addition to the new BU version is the highly improved heads-up display. It shows ground speed, airspeed, angle of attack, Mach number, G-load, recorded G-load since last reset, attitude using a pitch ladder, a flight path marker, a potential flight path marker, altitude, heading, destination information, the barometric setting, the active radar mode, time information, and navigation information like waypoint designation, distance to go, and estimated time of arrival. The heads-up display can be configured to show analog or digital information for airspeed and altitude. Furthermore, for altitude, either barometric altitude or radar altitude. Now use the display switch labeled HUD format to switch between analog and digital representation. And use the HUD Alt switch to select between barometric altitude and radar altitude information. Furthermore, use the brightness knob to change the brightness and the barometric setting knob, the black one, to change the barometric setting. Press spacebar to continue with the lesson. Also new is the vertical display indicator group replacement. The display can be configured to repeat the heads-up display, VDI, or show the video from the television camera set or the targeting pod, video. The repetition of the heads-up display makes flying with heads down easier, for example when flying IFR or when studying radar information or ECM pages. Now use the display switch labeled Mode VDI to switch between the heads-up display and the video. Furthermore, use the brightness knob to change the brightness and the contrast knob, the black one, to change the contrast of the display. Press spacebar to continue with the lesson. Furthermore, the horizontal situation display can be configured to repeat the tactical information from the back seat, PTID, or show the classical navigation page, NAV, or the new ALR 67 electronic countermeasures page, ECM. Use the display switch labeled HSD mode to switch between the tactical information, the navigation data, and the ECM page. Press spacebar to continue with the lesson. As you may have already noticed, the ACM panel was removed. The buttons and switches have been distributed around the display group. Let's find them again, one after the other. Confirm each item by pressing spacebar. The master arm switch was moved to the left. The ACM jettison switch was moved to the right. The ACM buttons Sidewinder cooling, missile preparation, and missile mode have been moved to the right side. The gun rate switch was removed. The new HUD cage switch is on the left side. The seam lock light, the collision light, and the hot trigger light are now to the right. The weapon station status flags are now on the very bottom of the VDI. Finally, the master caution push button is now left of the turn and slip indicator. Further improvements of the BU version are the following. The old automatic flight control system panel labeled AFCS got replaced by the digital flight control system labeled DFCS, which implements a number of stability improvement features. The switches on the panel didn't change. Check the highlight on the left side panel of the pilot seat. Press spacebar to confirm. Check the highlight just aft of the DFCS panel. The TACAN CMD button now selects either TACAN navigation or EGI navigation. The TACAN panel in the rear seat was removed, so the radar intercept officer may provide EGI-based navigation data, but no TACAN information. If you want to use TACAN-based navigation data, you'll have to configure your TACAN panel in the front seat. Press spacebar to confirm. The BU version brings the integration of the JDAM GBU-31 GPS-guided munition. Press spacebar to confirm. The old ALE-39 countermeasure system was replaced by the newer ALE-47 system. Therefore, the panel was replaced by a new one. In the rear seat, check the highlight on the right side panel. Mission Data Loader allows for the usage of data cartridges that allow for the loading of up to 12 flight plans with 50 waypoints each from the mission editor. Additionally, the MDL allows for the creation of countermeasure profiles for the ALE-47 and the pre-planning of JDAM targets. Press spacebar to confirm. This concludes the lesson. See you in the next one. Welcome to the Cold and Dark Startup Tutorial. In this lesson, you will perform the startup of the F-14B upgrade Tomcat from Cold and Dark on an airfield as the pilot. A prerequisite for this lesson is a familiarity with the controls and indications of the pilot cockpit, which you should have gained from studying the aircraft manual. This lesson assumes that you have no experience on the older versions of the Tomcat. We will go through an extremely abbreviated interior inspection procedure, the full pre-start procedure, the full engine start procedure, and the full post-start procedure for land-based operations. As you will notice, many steps during the startup are system tests, which you can always bypass by pressing spacebar during the explanations. The tests are not necessary because in DCS the aircraft is spawned in a perfect condition. All such steps are introduced with the phrase System Test in the on-screen text of the DCS window. Considering you set the system status correctly, you can always skip the instructions by pressing spacebar, although for many steps, it's better to listen carefully before taking action. Press spacebar when you're ready for startup. As you might know, the F-14B has a pneumatic engine startup system, and as it also lacks an APU, we have to order the plane captain to connect the ground air supply. We also have to order him to hook up the ground electric power. Use the communication menu under category F8, Ground Crew, and the following key bindings: F8, F2, F1 for the ground electric power, and F8, F5, F1 for the ground air supply. Press spacebar once ground electric power and ground air supply are connected.
Chief, turn on the ground power.
Copy. Ground power is now on.
Chief, connect ground air supply.
Copy. Ground air supply is now connected.
Adjust your seat height according to your body size. This is especially important for VR users. Use key bindings, seat adjustment down, and seat adjustment up to raise or lower the seat according to your needs. Press spacebar when you are sitting comfortably. Switch on the oxygen to your mask. Visually check that the wings are in the oversweep position and also verify that the emergency wing sweep handle is in the oversweep position, which is the farthest back position. Check that the white over flag is visible on the wing sweep indicator. Press spacebar to confirm. Set the hydraulic transfer pump switch to off. The guard must be up and the switch set to off. We've now reached the pre-start procedure. To allow communication with the ground crew with the canopy closed later on, set the following on your ICS panel: volume knob as desired, amplifier set to norm, function selector set to hot mic. Press spacebar to confirm. Ask Jester to initiate the startup using the Jester communications wheel. Use key bindings toggle menu and left control 3. The first step on his list will be to check communication. Respond that you can hear him by again using the Jester communication wheel. Use key bindings toggle menu and left control 4. Jester will also begin to start up and initialize some systems in his cockpit and will eventually tell you to arm your ejection seat. But please do not arm your seat yet. Press the spacebar when you've done the ICS check.
Okay. ICS comm check. Roger. Arm the ejection seat.
Check that the landing gear position indicator indicates all down and that the transition light is off. Press spacebar to confirm. Check all warning lights by pulling up the master test switch with a right click, rotate it to the LTS position with the left click, and then push it down with another right click. Verify that all warning, caution, and advisory lights illuminate. Coordinate with the Rio to check his lights. Use the already illuminated indications to set the brightness of the ACM panel and the indexer lights to a suitable level. The lighting controls are located on the master light panel on the right side. Press spacebar to continue. Now lift the master test switch and rotate it to the fire detection/extinguish position and push it down. Check that the left fire and right fire lights below the ACM panel illuminate and that the green go and red no-go lights on the master test panel also illuminate. Press spacebar to confirm. Next, lift and rotate the master test switch to the instrument position and push it down to check if the flight instruments show the following indications. RPM reads 96%, EGT reads 960 degrees Celsius, fuel flow reads 10,500 pounds per hour, AOA indicates 18 plus or minus 5, wing sweep indicates 45 degrees plus or minus 2.5 degrees, fuel quantity reads 2,000 plus or minus 200 pounds, and the RIO should also confirm that his indicator displays the same fuel quantity. The L fuel low and R fuel low caution lights illuminate. The L stall and R stall warning lights left and right of the HUD will be flashing. The oral stall warning sounds several times, and the oxygen quantity reads 2 liters. Press spacebar to confirm. Finally, make sure that the master test switch is set to off. Press spacebar to continue. Arm the ejection seat. Use the key binding, toggle arm ejection seat. Jester should have already told you to do so. Once you've armed the seat, Jester will close the canopy and tell you about it, and then continue with his startup. Recommend you tuck those fingers under your pits. Press the spacebar to continue.
Alright, let's start.
Check the closed canopy. This is a good moment to adjust the mirrors according to your requirements. Press the spacebar to continue. Now, check and set the following on the VDIG R bezel, the former ACM panel. Sidewinder cooling to off, missile preparation to off, missile mode to norm. Press spacebar to continue. Verify that the emergency stores jettison push button light is out. Press the spacebar to confirm. Verify that the ladder light on the caution and advisory indicator is also out. See the picture to see what it looks like if it's illuminated. Press the spacebar to confirm. Wait for Jester's confirmation that he's ready to start the engines. Most likely he's probably already given it. Press spacebar when he reports it's ready. Confirm that the air source switch is set to off. Press the spacebar to confirm. We've now reached the engine start procedure. You can then move the emergency flight hydraulic switch to low. Check that the on flag is visible in the emergency flight low hydraulic pressure window. Also verify the control over the horizontal and rudder control surfaces on the surface position indicator. Press the spacebar to confirm. Next, move the emergency flight hydraulic switch to high. Check that the on flag is present in the emergency flight high hydraulic pressure window. Again, verify control over the control surfaces on the surface position indicator. The deflection rate should be higher than in low. Press spacebar to confirm. Make sure that the emergency flight hydraulic switch is set to auto. Check that the off flag is present in both emergency flight low and high hydraulic pressure window, and finally, close the guard. It's now time to prepare yourself for the engine start, so let's quickly review the necessary steps before we start them. First, once you set the engine crank switch to left or right, it'll automatically be held in that position initially. Second, when the RPM reaches 20%, check for oil and hydraulic pressure and that the start/valve caution light illuminates. Third, when at 20% RPM, move the selected engine throttle to idle to actuate the ignition system and open fuel flow. Engine light off should occur within 5 to 15 seconds. EGT should peak around 40 to 50% RPM and should not exceed 890 degrees Celsius, which would constitute a hot start. Fourth, at 50% RPM, the engine crank switch will disengage automatically. Note, if the engine crank switch doesn't return to center after 50% RPM, set it to off manually before 60% RPM. If the start/valve caution light stays on, tell the plane captain to disconnect the air supply. Press spacebar when you've understood the procedure. Right-click the engine crank switch. When RPM reaches 20%, move the right throttle to idle. Let the RPM rise until the RPM value stabilizes. Notice the right generator caution light turning off at 59% RPM. Notice the right fuel pressure caution light turning off before idle RPM is reached. After the engine is stabilized, the instruments at idle RPM should read engine speed, RPM, between 62% and 78%, exhaust gas temperature, or EGT, between 500 degrees and 600 degrees, fuel flow between 950 and 1400 pounds per hour, nozzle position 100%, oil pressure 25 to 50 psi 15 minimum, and then check the flight hydraulic pressure showing 3000 psi. Press spacebar to confirm your checks. Order the ground crew to disconnect external power. Key bindings are the following: /F8, F2, F2. When done, press spacebar to continue.
Chief, turn off the ground power.
Copy.
Left-click the engine crank switch, but leave the throttle in off position for the moment. Wait to see that the combined hydraulic pressure reaches 3000 psi. Then switch the engine crank switch back to off. Press spacebar when done. Now, with the left engine spooled down again, switch the hydraulic transfer pump switch to normal. This should pressurize the combined side from the right engine and maintain a pressure between 2400 and 2600 psi. The needle will move slowly, so be patient. Note that if the right engine does not pressurize the combined side within 10 seconds, immediately set the hydraulic transfer pump switch to shut off. This situation caused by a malfunction in the hydraulic system, which you cannot fix, and it requires you to hop into a spare jet. Press spacebar to confirm. Set the hydraulic transfer pump switch to shut off. Next, start the left engine the same way you started the right one. As a reminder, the engine instruments should read engine speed, RPM, between 62% and 78%, exhaust gas temperature, or EGT, between 500 degrees and 600 degrees, fuel flow between 950 and 1400 pounds per hour, and the nozzle position should be at 100%. Oil pressure should be at 25 to 50 psi, with a 15 psi minimum. This time, check the combined hydraulic pressure is reaching 3000 psi. and press the spacebar when done. With both engines running, order the ground crew to disconnect the air supply. Key bindings are the following: \, F8, F5, and F2. Press the spacebar when done.
Chief, disconnect ground air supply.
Copy. Ground air supply is now disconnected.
Cycle the air source switch, first to left engine, followed by right engine, and finally to both engines. Finally, set the hydraulic transfer pump switch to normal and close the guard. It's now time to take care of Jester and the INS alignment. The INS alignment process can take up to 8 minutes depending on conditions, so it's best to start it as soon as possible after the engines start. It requires the parking brake set to on. Note that the alignment will stop if the brake is released. To see how the alignment is progressing, turn on the HSD and set it to TID repeat. Jester would normally go for a so-called fine alignment, but if required, you may change that. Once you see data on the HSD in TID mode, you can open up the Jester wheel and select the desired INS alignment quality. For today, please let Jester align it fine. You will also see that Jester enters the required parameters for INS alignment and also the alignment mode.
Roger that.
When the INS alignment starts, the TID repeater shows a status bar on top of the screen with a diamond moving from left to right. The more right, the finer the align already is. The time already elapsed in the alignment phase is also shown. We're now free to continue our checklist. Press spacebar to continue. We have now reached the post-start procedure. Turn on the Stability Augmentation System, or SAS, by setting all 3 SAS switches to on: pitch, roll, and yaw. Now switch on the VDI and the HUD. The HSD should already be on. Next, we will check the Augmenter Fan Temperature Control, or AFTC. For this, set the left engine select switch to secondary and check that the left engine secondary light illuminates on the caution panel, and the left nozzle position indicator points below 0. Advance the left throttle slightly and check good engine response. Then set the switch back to primary and check that the caution light goes out, the nozzle position indicator again shows 100%, and then repeat the check for the right engine. Press the spacebar when done. Set the external transfer switch to position off. Next, let's take care of some other systems. Set the UHF function selector to both. Set the TACAN function selector to T/R. Turn on the radar altimeter by rotating the control knob. Turn on the ICLS ARA63 power switch. And turn on and configure all displays as required. Press the spacebar to continue. Set pitch trim to 0. With no control input, it should read at 0 degrees on the surface's position indicator. Check it carefully. Press the spacebar to confirm. Erect the standby attitude gyro by clicking the control knob with the left mouse button, and then turn it with the right mouse button until the waterline is centered. The gyro should be erected at least 2 minutes before takeoff. Press spacebar to continue. Press the Master Reset push button. Now, extend the speed brake partially and retract it. Then extend it fully, and again, retract it. Check for a positive change on the stabilizers in order to verify that the automatic trim is working properly when the speed brake is extended. Press the spacebar to continue. Extend the refueling probe fully by setting the refuel probe switch to position all. Check for normal operation and that the red transition light illuminates when the probe is in movement. Finally, retract it by setting the switch position back to retract. Press spacebar to continue. In the following steps, you test certain interlocks in order to prevent the aircraft from damaging itself while moving wings and control surfaces. You may or may not perform all these tests. Either way, it's important to at least set the wings, slats, flaps, etc. to the required position as instructed, because otherwise you might end up with the wrong aircraft configuration in the end. Required settings are labeled required in the on-screen text. Now, coming back to the post-start procedure, the next step, which is number 27, requires you to extend the wings. It's therefore absolutely critical to verify that they can extend and don't hit anything around you. Press the spacebar to confirm that the area around your aircraft is clear. First, move the emergency wing sweep handle to the fully forward position, 20 degrees, by moving the handle with the left button or by using the scroll wheel on the mouse. Then, engage the spider detent by pushing the handle down with the right mouse click. Close the guard with the left mouse click. As the wings come out of their oversweep position, the HC tail authority light will illuminate momentarily as the stabilizer locks disengage. Check that the wings finally reach the full forward position. Press spacebar to confirm your checks. Finally, press the Master Reset button to reinitialize the automatic wing sweep program. Set the external lights according to the situation and check their operation. Don't forget to turn on the master light switch on the throttle in order to really turn the external lights on. Press spacebar when done. Fully extend flaps and slats by moving the flaps lever fully aft. Check the corresponding indications on the flaps and slats indicator. Also check for full deflection of the flight controls, the operation of the outboard spoiler module, and the horizontal stabilizers moving up to 3 degrees. Press spacebar to confirm your checks. Verify full range of motion of the control stick and the control surfaces and that they move with normal speed. Press spacebar when done. Enable the dynamic lift control system with the DLC button on the control stick. Use keybinding DLC toggle / countermeasure dispense. Verify a small trim change of the horizontal stabilizer. Observe the spoilers coming out about a quarter of the full range. Set the anti-skid spoiler brake switch to position spoiler brake. Apply power slightly above idle and check if the spoilers retract. Then, set the throttles back to idle and observe the spoilers extending again. Press spacebar when done. Set the anti-skid spoiler brake switch position back to off. Retract flaps and slats by moving the flaps lever fully forward. Now rotate the DLC thumb wheel on the control stick aft to extend the so-called maneuver flaps and slats. Keep pressing the thumb wheel until the maneuver flaps and slats are fully extended. Look out and observe the leading edge slats coming down a few degrees, and also observe the changes on the flaps indicator. On the other hand, the slats indication should not change since slats extension is small and not considered by its own dedicated indicator. Press spacebar to confirm your checks. Manually command the wing sweep to 50 degrees by using the wing sweep mode switch on the throttle lever, keybinding wing sweep aft. Observe the wing sweep indicator following your command until the wings finally reach 50 degrees. Press spacebar to confirm your check. Now retract the maneuver flaps and slats partially by doing just a very quick press forward on the DLC thumb wheel. Command the bomb mode using the wing sweep mode switch. Check that the wings will sweep back to 55 degrees. Also check that the maneuver flaps and slats retract fully. Press spacebar to confirm your checks. Now open the guard again. Pull up the emergency wing sweep handle and wait until it becomes free to move. Move the lever back to the 68 degree position. Note that you cannot go further back until the oversweep lock opens, which takes a few seconds, so be patient. When the oversweep indication appears, move the wing sweep handle even further back, but please don't push it in. Look out and check that the wings move into the oversweep position. Press spacebar to confirm. On the radio altimeter, press the set knob to initiate the built-in test, abbreviated BIT. The display should indicate 100 feet and the green light should illuminate. Then release the knob. The display should then show 0 feet, the altitude low light should illuminate, and a warning tone should be heard by both pilot and RIO. Press spacebar when done. Check all displays for the desired mode. Typically the VDI repeats the HUD and the HSD repeats the PTID during that particular phase. Press spacebar when done. Set both the cockpit and the HUD altimeters to the desired QFE or QNH values. For example, you could use QFE on the cockpit altimeter and QNH on the HUD altimeter. Then reset the cockpit altimeter by turning the small latch on the bottom to position reset until the red off flag disappears. Press spacebar when done. Validate the IMU heading on the HUD, the VDI, the HSD, and the BDHI. Cross-check them against known references and the standby compass. Note that until the INS alignment is complete, these displays show degraded information. Press spacebar when done. Check all flight instruments for normal readings. Press spacebar when done. Good. Jester has finished the alignment. You've successfully completed the aircraft startup procedures for land-based operations. This concludes the lesson. You're now free to perform a takeoff on runway 31. Here are the abbreviated checklists with the most important items. Don't miss them. Press the spacebar to stop the music and remove this text from the screen.
Chief, remove the wheel chocks.
Copy. Wheel chocks are now removed. Clear to taxi to runway 31. Dodge 1, unable to clear for takeoff. Dodge 1, Batumi, you are cleared for takeoff when ready. Climb 300 at QFE 29.89.
Man, the CO will bust our balls for that again.